All right, we're going to continue looking at waveforms. Last video, we discussed functional diagrams, which explain just the logic. And now we're going to move to a timing diagram, and this will show the delay of our circuit. So we're going to start off simple, just like we did last time. And here we have a simple NOT gate. So we have X as an input. It's going to take 10 nanoseconds to evaluate, and then we'll see a change on Z 10 nanoseconds after it. All right, so we have this small little diagram here. And let's just put in our times. So everything is 10 later. Now, what we're going to do is we're going to take a time. And let's say, let me do this in a different color. That way it's a little bit easier to see. And in order to evaluate Z here, we're always going to look back 10 nanoseconds because that's how long it took us to examine it. So the first time we do this, we look backwards 10 and we don't have any value of X. So we're just going to put X's to say we don't know what was the value we should be. Different simulators use different ways to determine this. Sometimes simulators throw in initial values. Sometimes it's an X. Sometimes it's a U for unassigned. You can kind of get the idea. Then we can look at, here's our new value of X. We need to look back 10 nanoseconds. Now we start seeing this is where we're starting. Or we can say where we start, we go forward 10. However it is you want to look at it. And our X was a 0, so it should have flipped to become a 1. Then if we keep going forward, it's a 1, so we should see it come down to a 0. It's a 1, it should be a 0. Here's the 0, we should see it pop up to be a 1, go back down to a 0, a 1 to a 0. And then here, when we get to this final one, it would have popped up 10 nanoseconds later. Now, this timing diagram, once we start putting in delay, can become a little confusing. So it's best to do it one time step at a time. So a time step is you should look at what is your changes, and from your changes, work through there. Okay, so now we're going to have this bigger diagram here. So here we have 3 gates in total. We're going to say all of these are still 10. Okay, we're going to make everything simple. How long every type of gate should take kind of depends on the technology we're using. A lot of times we would say, a NOT gate probably is faster than, a 3 input AND gate. A 2 input AND gate is probably faster than if we were to have like a 6 input AND gate. Okay, so this circuit becomes a little bit more challenging, like I said, because you have a lot of delays that are happening. All right, so we're going to keep everything solid of 10 nanoseconds. So we're going to start here. And where we're going to start is we're going to take our first values of A, B, and C. And we won't see anything that happens till after that a case occurs. And then our Z is X or C. I forgot to write that down. Okay, so at this first timing item here, we look at A, and A, for any change to occur, I'll do this in a different color here. It was going to take 10 nanoseconds for us to see an X popping up. So for all that time, our X was unknown. Our A bar was unknown. And then it's a 0, so we would expect it to become a 1. Our X value here was based off of A bar and B. So let's do A bar in green here, and let's do this X in blue. Okay, so I'm looking at A bar, and then I'm looking at B at this time of 0, and I won't see anything happen until 10 after that. Well, if A is unknown, well, then X will also be unknown. We don't know what the value is. And then let's do Z here in orange. So Z is based off of X, and then it's based off of C. And I won't see anything till 10 nanoseconds later, and I do that, and X is unknown, which means um, Z would also be unknown. I probably went too far ahead on this blue. Let me erase that. We're going to do everything one time step at a time. Oh, no, that was right. I'm sorry. So one time step. So I don't know what anything is for those first two timing pieces. Okay, now we're going to move to the next time. So that was at 0. Now we're looking at what happened at 10 nanoseconds. So at 10 nanoseconds for A bar, we go back. It was a 0, so we expect it to be a 1. Now we're going to go down to blue. We expect it to be B now is a value of 1. And now our A bar also has a value of 1. So 1 and 1 is a 1. And then we go to our orange piece. Our orange item is X or C. So X is here. Well, if X is unknown, then our Z will be unknown. So we can put in unknown at that point. All right, then we're going to move over to the next time period. Here's A is a 1. If A is a 1, our A bar becomes a 0. Then we're going to look at the blue piece, and our blue piece now is A bar, which is a 1, and B, which is a 1. So 1 ended with 1 is a 1. And then we're looking at orange, which is X and C. So we have a 1 or a 0. Well, that would be a 1. Now I'm drawing in all these lines, and as you see the lines, they kind of make everything, very messy. So later you probably will want to go through and clean this up. But you kind of want to follow this process because everything follows, one gate delay after the other. So you kind of want to move one, let's say, vertical column at a time. So let's just do one more to complete this out, and then we can end this. Okay, so let's say we're now at the next time period. A is a 1, so A bar would be a 0. We go to blue, A bar. So we're looking at this item, and we're looking at B. So we're at a 0 and a 0. Well, 0 and 0 is a 0. And then we'll go to our orange piece. Our orange piece, we are looking at X, which is a 1, and B, which is a 0. Well, those are OR together, so we would still be a 1. All right, so that gives you an idea of how our, timing diagrams would look. If we were to clean this up, let's see if we can do it without destroying everything that popped up. Your diagram starts looking a little bit cleaner there. However it is that helps you get through this, drawing it out. All right, so that takes care of, our simulation piece. You saw how to make a simulator using that Circuitverse web program. We talked about function diagrams, which just look at the logic of, we just pinpoint what the output should be on a waveform showing how items will change over time. And then this last piece is our timing diagram, which looks at the actual delay of our gates as we move through the circuit. Right, so that takes care of all the simulations of module 7.